Welcome to our workshop today, titled AI-Enabled Medical Platforms and the Partnerships for Delivery. My name is Don Schlitt, and I serve as the President and CEO of Dedicated Computing. We've had the privilege of presenting at this conference for the last several years, and we're proud to be back again this year. This year, for the first time, we're bringing in some partners, which I'm really excited to introduce to you to share their thoughts on the exciting growth in the field of artificial intelligence. Our first guest with a key customer of Dedicated is John Cifarelli. John's the Chief Commercial Officer for a company called DocBot, and will provide you some details about the innovative work they're doing in the area of artificial intelligence in medical devices. I'm also pleased to introduce Rupali Deshpande from NVIDIA, a leading healthcare company providing interesting technologies into an array of customer applications, and certainly is a leader in its field. You'll hear more from Rupali later in our workshop today. As we move forward, we're going to be walking through a case study that provides some interesting details as it relates to a specific global medical device company that's developing next generation technologies. In the workshop, we're going to be talking about our partner ecosystem and the way that we're developing products from startup through to mass distribution. Dedicated Computing's mission is powering the world's most important devices. Our interest in this field of artificial intelligence has really been a part of the history of the company for over 10 years. Powering the world's most important devices to us really starts with the customers that we work with, companies like DocBot, who are delivering innovative solutions into the healthcare space, and we're proud to be affiliated with them. But a key part of it is also linking together key partners and technology innovators such as NVIDIA to bring that as we go forward. Today, we're going to be talking through a really interesting life-saving application of artificial intelligence, and you'll hear from John about that in just a minute. At the end of the presentation, we're going to afford some time for questions. We hope you hang around and take some time to get any thoughts you can from John or Rupali after they share their remarks. At this point, I'd like to introduce John Cifarelli with DocBot to give you an overview of his company and their solutions. John?
Thank you, Don. Welcome, everybody. DocBot is we're a small startup company developing artificial intelligence in the medical community and primarily focused in the field of gastroenterology. Our initial product is in the colonoscopy market. I'm sure everybody's familiar with colonoscopy. It's a great screening modality. It's actually the most effective screening modality of all, including Pap smear and PSA. But however, with all human components, there are some things that need to be improved. Colon cancer is still, an extremely large volume of cancers in the United States. And our goal is to reduce that down to zero. Traditionally, a person goes in for a colonoscopy, and the idea is to get your polyps removed, and physicians have to find those polyps. And certain polyps that are precancerous are called adenomas. And those are the ones you want to surely get resected out. It just turns out that, unfortunately, about 50% of all people who come in for a colonoscopy have an adenoma in there. Yet, it's been shown that physicians' adenoma detection rates vary from a low of 7%. Don't worry, there aren't too many of those, but to a high of 53%. With the average adenoma detection rate is somewhere between that 30-35 range. And it's our goal to get everybody back up to that even playing field of around 50%. To date, our system has shown that it helps increase a physician's adenoma detection rate around 17%. And any time you can improve an adenoma detection rate, every 1% increase in adenoma detection rate will lead to a lower of interval cancers of 3 to 6%. So you can see how valuable it is to help improve the detection of cancer. And the system is designed to help a physician be a second set of eyes while it looks at the colon during the exam when the physician's performing the exam. We're going to show a brief video that's going to kind of like show you how the system works. And I think, obviously a picture's 1,000 words. So here's the video. And as you can see the system, we're showing two monitors in this system. And ideally you would not use two monitors. The physician would just look at one. The reason we're using two is we're just trying to demonstrate the real-time effect of the artificial intelligence. You can see the boxes going around a polyp. From one monitor to the other, there's no lag time. We've been able to design this system we analyze more than 100 frames per second without any lag. Just amazing. And the system's been based on over 20 million annotated images curated over 7 years. So it's pretty impressive. And we're really proud of the system we have. Together with our partners, we're looking to expand our system and take it to the next level. It's going to take us a little bit of time, and we have some more work to do. But the real goal is to move from just polyp detection to polyp classification. In the United States, about $1 billion a year is spent on pathology of benign lesions in colonoscopy. Generally, physicians remove every polyp they see, and polyps that are about 5 millimeters or less, 80% of those times, those are benign. Yet, they're removed and need to be reviewed by a pathologist. And that incurs a cost of about $1 billion per year to the healthcare system. We believe with our system, we'll be able to determine what those polyps are. As you saw in the video, there were some that were called hyperplastic and there were some that were called adenomas. Hyperplastic are those benign polyps. And those are the ones that we think we can get to the point where a physician can see them, trust that it's benign, and just cut and discard and save that pathology cost associated. Like I said, it's over $1 billion within the US, which is, as you know, significant. But we need to count on our partners to be able to do that and improve the system. And that's why we're really happy to be partnering with Dedicated, who is the brain power behind our solution. And we're forwarding with NVIDIA's Quattro Pro GPU processing card is the heart of the system. So we're really excited to be working together with our two partners here. This platform, combined with Dedicated's market expertise and NVIDIA's development tools, have provided us with the technologies and support to enhance our algorithms and to help to try to eliminate colon cancer. So we're really happy to be partnering with our two partners here, and we're looking forward to advancing healthcare and advancing patient outcomes. And with that, I'll hand it over to Rapoli.
Hey, John, before we hand over the ball, I just want to make one comment. That video is very powerful. I mean, I'm not a gastroenterologist, but when the first time you showed me that video, I think the power of what that technology provides in terms of, greater visibility to polyps. And certainly, as I think about healthcare moving towards more of an outcomes-based type of environment, I've got to believe the reception for that technology has been very strong. Is that true?
Yes, it's very strong. Yeah. I think it's pretty well accepted in the GI community that, artificial intelligence for screening and all diagnostics is going to be a big component. You see it already in the field of radiology where it's a dominating component, and it'll move to all diagnostics. And obviously, the field of gastroenterology is expecting it to be a standard of care over time for colonoscopy.
Sure. Well, terrific. Thanks for coming by today, and we're looking forward to have you stay around for the question and answer session as well. As John mentioned, that's a computationally intense process that video certainly simplified for you. But as you can imagine, there's quite a bit behind that from a technological might. While Dedicated, we certainly are proud to be a part of the solution for DocBot. We couldn't do it without the technology leadership that we gain by having a partner such as NVIDIA, and we're proud to have them join us as well. As I mentioned before, Rapoli Deshpande from NVIDIA is here today, and she's going to take some time to talk to you about NVIDIA and their view of artificial intelligence in the healthcare market. Rapoli?
Yeah. Thank you so much, Don. Thank you very much. So hello, everyone. So today I'll give a quick sneak peek into how NVIDIA is changing the world of healthcare through our technologies. So yeah, next slide, please. Okay, so before I really get started, just wanted to give you a quick background about NVIDIA. So as you all know, we started our journey from the world of graphics, accelerating like one of the most complex workflows of 3D rendering, gaming, and 3D graphics. So then taking the same GPUs and the technologies, we entered into the world of compute. And through our parallel computing platform called CUDA, we accelerated like almost every HPC application on the planet, giving like 8x, 10x, or even 20x speed ups over CPUs. And again, taking the same technology, we entered into the world of AI. So today, if you really see, like with all these three technologies, graphics, compute, and AI, we are accelerating like almost every industry on the planet, whether it is the self-driving car industry, or it's media and entertainment, or oil and gas, finance, or it could be like one of the most important industries of today, which is healthcare. So today I'm going to talk about how NVIDIA is changing the world of healthcare. So let's take a quick snapshot. It's a video to which you will get an idea how we are empowering the world of healthcare. So if you can play the video, please.
A lot of people know about NVIDIA from gaming, from virtual reality, and from the work that we do in self-driving cars, but people don't realize that we've been in healthcare for about 10 years. Physicians are our heroes. They save lives every day. The question that we ask ourselves at NVIDIA is, how do we give them superhuman skills? How do we make the instruments that they use today stronger and better for what they're trying to do? It turns out that GPUs do this all the time. GPUs are able to accelerate these instruments so that we can scan people faster. GPUs are able to visualize things better so that they can see cancer clearer. And now with deep learning, we can even provide them with more information about the patient. When I get on a plane, I never think about who is going to pilot that plane. I don't think anyone does. And the reason we don't is that pilot has a co-pilot all the time, and it's called autopilot. Unfortunately, we don't have something similar in healthcare, but I think that AI can provide it. Our bodies are so complex. The only way we've been able to attack cancer is by specializing. We specialize in liver cancer, we specialize in brain cancer. By training an AI with their own knowledge on how to diagnose this specific disease, that network could then be taken and provided to all the different physicians around the world, not just in the US, but around the world, so that we can get that high level of care provided to everyone that we know of. MRI is one of these modalities that are amazing, that can tell you so much about the body. We don't use it as much because it takes so long to do. Deep learning has been revolutionizing the way we do medical imaging research. That could actually bring MRI scans from taking 30 minutes to 3 minutes, making it accessible to everybody around the world. So how do you bring all of this amazing intelligence that's being developed to the instruments that are out there in the market? It turns out that there's about 3 million instruments out there on the market today, and only about 100,000 get sold every year. So in general, instruments live for about 10 to 15 years. Their sensors are fantastic. The screens that they have are fantastic, and radiologists can use them. Their brain happens to be 15 years old and is not capable of doing what we want them to do today. So we need a way to actually bring this technology to the instruments so that we can empower the radiologists. We recently announced a new GPU computing platform called Clara. It accelerates medical imaging instruments, including all of their workloads, from reconstruction of the image to rasterization of this image, to ray tracing, all the way to applying deep learning algorithms to it, enabling us potentially to do early detection of disease so that we can catch it earlier and treat people better. Working here at NVIDIA, I'm hoping that all of us will have the opportunity to contribute to making healthcare better for everybody in that way.
Okay, so that was a summary on how we are seeing the future of healthcare, and how we are changing the world of healthcare through technology adoption. But yes, the big challenge is how do we make this technology adoption easier? So this is a quick snapshot through which I'll help you understand how NVIDIA is helping this technology adoption. So one is with our hardware. So of course, GPUs are the backbone, of the healthcare and the medical instruments industry. So we have GPUs ranging from data center to the edge, where you can actually deploy GPUs inside smallest of the instruments, even like something like smart camera, which can run inferencing workloads. But then having just great hardware is not enough. I mean, if you really want the hardware to run efficiently and effectively, we really need to have world-class software. And hence we have this software platform called Clara, which we specifically built for the industry of healthcare. So through this software platform called Clara, we are giving like a starting point to our developers to develop algorithms or applications related to healthcare, through which they can integrate the features like compute, graphics, and AI. For example, you can have like applications like real-time endoscopy or even like diagnostic imaging, through which you can integrate features like AI through our Clara platform. So, which includes features like we have pre-trained models, so that the developers don't have to train their models from scratch. You can just take the pre-trained models and build on your own data. So by the way, these also include COVID-19 models. Then we have features like federated learning, where you can actually take the model to the data, and the model can learn from the data and then just come back. So in this way, we are preserving the data privacy of patients. Also, one of the other important features is like AI-assisted annotation. So as we all know, right, annotation or data labeling is one of the most crucial processes in the AI workflow. And especially when it comes to the medical data, it gets even more tricky because it really has to be done by the experts. So through AI-assisted annotation, we are bringing the expertise of AI to annotate the medical imaging data. I mean, we're just automating that whole process with the help of AI. So there are so many such features through which we are trying to make the technology adoption into the world of healthcare like so much more easier. Then we also have the NVIDIA EGX platform, through which you can have all these technologies running on the cloud. You know, you can even have your medical instruments connected to the cloud so that they can be updated with all the latest and the greatest technologies. So it's basically Clara platform is like an end-to-end application framework through which we are making the technology adoption easier for the world of healthcare. Now, again, of course, we have this great hardware, great software, and all these great technologies. But we as NVIDIA, like our challenge is, how do we make these technologies accessible to our customers? How do we make sure that these technologies reach every doctor and physician out there? How it gets integrated into every instrument out there? So that's where our partners like Dedicated Computing plays such a crucial role. I mean, they help take our technologies to our customers. They help integrate the hardware and software into the customer's environment. So we, with partnership with Dedicated, are developing joint solutions which can make this whole technology adoption easier for the healthcare domain. So all I can say that this is just the beginning. The future is so much more exciting. So thank you very much. And back to you, Don. Thank you.
Thanks, Rupali. It's exciting. I know you're proud to work for NVIDIA. I think in this day and age when so much is focused on COVID, as it rightfully should be, hearing about what's next is important, because there will be a what's next in the world of healthcare and the world of technology innovation. And we're really excited as our company approaches its 40th anniversary to see how healthcare has evolved. And I couldn't have imagined 10 years ago companies like NVIDIA and DocBot even existing, much less leading in their respective fields. So we're proud to bring you both forward and be a part of the presentation today at the AMD organization. This is certainly a great conference, and we hope you can come back again in the future. As we wrap up, I know this was a brief snippet of information that'll be available to you as you go forward. There are certainly a number of other relevant topics that we're happy to share our thoughts on as it relates to questions and resources in the field of product development, working with suppliers, and certainly the continuing body of knowledge around artificial intelligence and the medical image. On your screen, it just listed a couple of resources that you can find on the Dedicated Computing work page. Use them at your leisure. At this point, we're done with sort of the prepared remarks. We'd like to wrap up this portion of the session and turn it over to the audience for some live questions. I want to thank everyone for joining us and hope you enjoy the rest of the conference. Take care.